I stand before you today on the main campus of the University of Cape Town, South Africa. Off to my left are most of the campus's science buildings, including mathematics, computer science, statistics, biology, physics, and so on. And off to my right are most of the campus's humanities buildings, including language studies, politics, philosophy, social sciences, and so on. Now, let me ask you a question. How many of the nuclear physicists from that side do you think can recite a verse of Shakespeare? How many of the political philosophers from that side do you think know what the second law of thermodynamics is? Probably not many. And they'd probably be inclined to ask why. Because most scholars don't even bother with closely related fields, never mind fields on opposite sides of this science-art gap. I think this is a great place to make my point because it's precisely this gap that often goes overlooked. Scientists don't care much for poetry because it doesn't help them uncover and manipulate the laws of nature. Similarly, artists don't care much for integral calculus because the world will keep on turning just fine whether we know how it does that or not. See, this is the mindset that most academics take on, and it starts right here at university. See, in high school, your options for specialization are very limited. I mean, where you can choose between subjects, you usually have to take some humanities subjects like languages or life orientation and such. And besides that, you have to socialize with everyone in your school, or I mean, at least everyone in your grade, seeing as the limited number of options that you have as a student. But all this changes when you hit university. You see, because now all of a sudden your world of opportunities changes from a few hundred students to the order of tens of thousands of students. And if you have a half decent university executive, you have the studies of all these students organized into departments and faculties and such. And if you're as explicit as the University of Cape Town, you have all the humanitarians on one side and you have all the scientists on the other, and right in the middle you have a massive gap. So what ends up happening in these situations is you tend to stick to the same department. You go to class with the same people, you do the same work, you see the same lecturers. You very quickly find yourself a lab where you can hunker down and do some work in peace and quiet while surrounded by like-minded people. And so when you graduate, you do know a lot about subatomic quantum mechanics, but not much else. This will be my final year studying here at UCT. And if the pandemic doesn't wipe us all out, then by the end of this year, I should have graduated with a bachelor's degree in computer science and philosophy. Now, I can count on one hand the number of people I've met that have studied both in science and humanities at the same time. But I'm a reasonable guy. Look, I understand that not all courses allow you to just conjoin your subjects the way that I do. But a surprising number of them do. And look, all of the science students that I've spoken to are very antagonistic when I mention even taking electives from humanities. Let me tell you that a scientist in the communications class is about as rare as cookies in an orphanage. Hell, it's pure luck that I landed where I did. I used to be a narrow-minded scientist myself, until one day in first year, through some bad timing on the university side, it so happened that one of my first year maths modules took place in the social sciences building. And it was here that I coincidentally ran into a group of philosophers who convinced me to come to a philosophy society talk that evening. The talk was on the philosophy of mathematics, which I didn't even know existed up until that point. But this talk engaged me so much, and after a long debate on whether calculus was invented or discovered, I decided to merge my majors. But I'm one of the lucky ones. Look at any scientific academic's CV and you'll find a substantial number of books, textbooks, and papers authored on exactly the same topic. It has to make you wonder whether they're missing out. Could considering the work of other fields make a difference? I know so. I want to introduce a concept that's recently hit the public that tries to alleviate some of these problems that come of the science-art gap. It's called STEAM, and it quite literally places art inside STEM. It alleviates these problems by building a bridge over the divide and asking scientists to be more humanitarian in their work. Let's look at some examples of where it could help. There are three key aspects I want to discuss. First off, there's the question of necessity. Citadel Securities is a company that provides high-frequency trading services. For some perspective, every day their automated systems move about 35 billion US dollars in trades. In high-frequency trading, the name of the game is quick decision making. The faster your algorithms are at making those trading decisions, the better your company does. And Citadel has made a fortune doing just that. In fact, at the moment they have about 1,400 employees all over the world, most of which are software engineers and financial market experts and such, and they all have a singular goal in mind, and that is to reduce trading time. Do you think that's what humanity needs? 1.7 milliseconds quicker in this really specific trading algorithm? Because that's what that 1,000-odd employees have been doing for the last 3 decades. Can you imagine what they could have come up with if those brilliant minds were busy doing something more substantial? And then, of course, there's the question of morality. In 2003, the police department of Reading, Pennsylvania, invested in crime prediction software called Predpol. The purpose of this investment was to reduce the cost of policing in particularly troubled economic times. Within a year, the burglary rates of the city went down by about 23%. But as I soon found out, this came with quite a significant cost. Not financially, but morally. See, what happened was while crime rates dropped, arrest rates soared. And when the developers went to investigate why, they found that the system had grown a very, very strong bias towards low-income neighborhoods. What would happen is the system would send police into low-income neighborhoods. A great deal of arrests would happen there, like disproportionately to the rest of the city. And then that would be fed into the system, and the system would keep on growing the bias and sending police officers to low-income neighborhoods. And the thing is, the crimes that occurred in these neighborhoods, or rather the causes for the arrests, weren't so much violent or substantial by any means. They were very much what they call nuisance crimes, things like smoking marijuana and underage drinking. So this feedback loop contributed to the mass incarceration of hundreds of thousands of people for victimless crimes. And you have to ask yourself, if the purpose of policing is to reduce violent crime, then can you really say that the developers of the Predpol system thought their purpose through? And let us not forget the question of empathy. Between the 1930s and the 1970s, the US Department of Health conducted a study on syphilis in Macon County, Alabama. The study is called the Tuskegee Syphilis Study, and its purpose was to understand what syphilis does to the human body over time. 600 men were told that they had syphilis and that they were going to get treatment for it. About 400 of the men did actually have syphilis, but in reality, none of the men received real treatment. They all received placebos because the true nature of the experiment was to understand what the disease does when left untreated in the human body. Remember, this experiment lasted for about 40 years. In the middle of it, in the year 1947, in a completely separate study, they discovered that penicillin was an effective treatment for the disease. Yet, the original researchers from the Tuskegee experiment did not give penicillin to their subjects and just continued the experiment. By the end of it all, many of the men died, 40 of the wives contracted the disease, and 19 children were born with syphilis. If any of the researchers involved in this experiment had but an ounce of empathy, they would have stopped it when they realized that there was a proper treatment available for syphilis. Or they would have probably stopped it before it even began. It takes but a bit of decency to realize that the potential knowledge gained from an experiment like this is not worth the humanitarian failings that it exhibits. So now that we know about the dangers of putting scientists in silos, how do we get them out? Well, I'm not the first person to think about the value of seeing. In 2015, the government of Finland created the Department of Experimentation, which is responsible for making sure that experimentation into new fields is ethical and safe. The Federation of Atomic Scientists was created shortly after the Manhattan Project, and it endeavors to make the research that scientists and worker engineers do of a high ethical standard. And look, to their credit, most universities actually have ethics committees that review research work before it starts or sometimes before it's published. These are all very decent initiatives, and they do go a long way bringing the humanities into science. But if you ask me, they're just treating bullet wounds. If we want to solve this problem, we have to remedy the cause, that is, the metaphorical gun itself. And where does this science-art gap start? Right here in the literal middle of university campuses. So why not shuffle around the buildings a bit? Or you know what, better yet, let's do away with per department buildings altogether. Let the English majors have their tuts in the biochem labs. Let the mathematicians write an essay on the existence of God. Teach the physicists how to dance and the biologists how to write poetry. Because you know what? This world's problems aren't going to be solved by individuals. It's going to be solved by working together. I leave you with a very relevant quote from Ian Malcolm of Jurassic Park.
I don't think you're giving us our due credit. Our scientists have done things which nobody's ever done before.
Yeah, but your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should.